Hi everyone and welcome to this data structures and algorithm mastery course, and I hope that you had got better familiar with all those kind of stuff, whatever I taught you till now about recursion, and then we have talked about time complexity analysis, and soon the linked list videos will be uploaded soon. So what I plan is I have only one lecture on time complexity which explains here about some notations and terms, and what I just realized that taking out a theory is not good. So what I plan is I'm going to take out so much of examples of time complexity analysis to make you understand time complexity a very much comfortable way, and also we'll be taking out a time complexity of some searching algorithm, then we have a sorting algorithm, and just like that. And then in the next video, we'll taking out for the recursion, taking out the time complexity of recursive algorithms. Okay, so without wasting time, let's get into it. So what's the time complexity of linear search? But before that, what I want to just ask you, what a linear search is just a simple searching algorithm. I have not taught till now about searching and sorting algorithm, but in practice you can say that we are given an array, and we are given a number, let's say a number 8, okay, and this array is full of 8, 10, 11, 8, 9, 10, 11. Okay, so this is our array, and we are given, and with the help of linear search we have to go at the first element. We'll check if 8 is present there at index 0 or not. It will not, so we'll move on to the second, and then it is present or not, it will move on second. So it is present, so it will return the index, so 0, 1, 2. So linear search will give out 2 as an answer because it is telling that 8 is present at the index number 2. Okay, so this is what a linear search is. So what I've just planned is we're going to take the time complexity, how much time this takes for linear search. Because what is time complexity? We are on the basis of our input, we are going to take out the time. Okay, but if you have not watched my first video, be sure to watch that first video of this course, means time complexity analysis. Okay, so there are two cases. The first case is a best case. The first case is the best case, and the second case is the worst case. We only care about worst case because in the worst case, what is the time complexity? What will the time in the worst case? So the best case would be, what is the best case where we don't have to do, our algorithm will not have to do any kind of work. So if our element is present at the first index. Okay, so this is our array. This is something like 10, 11, 12, 19. So if it is found at element 0, so it will return 0. Linear search will not have to go at every example. So this is the best case if you're lucky. If we got the best input. So we have input, and we are taking the input, and on the basis of input we are searching. If it is, and we are lucky that we have found in the first index, so it will return 0. So this is the best case, and the time complexity takes only one time. So it is a constant, so it will give it a order of 1. But we don't care about the best case. We only care about the worst case. So when someone asks you about the time complexity of linear search, you will only tell about the worst case. So the time complexity, how to calculate? So you can see here, what is the worst case? So here I had written one. Let's take an example. This is our array. And the worst case is our element is not present. Here. So this is our thing, and our element is not present here. So let's say we have n equals 8, so we have 10, 11, 9, 7, 6. So it will go at, linear search will go at first. No, it is not. Second, third, fourth, fifth. It is not. So it is going at every element, comparing with it, and then move further. So it is going at first element, comparing with it, and moving further. So what is happening here is it is going at k times, which is going means comparing the two and then move back, comparing the two and then move back. Okay, so the time complexity would be it is going n times, so k times n. K times n, it's comparing and then moving up. K times n, this means in the first it's going k times 1, it is going second, it's k times 2, going third, it's k times 3, going fourth, so all the way down to the n, number of element here. So it will go k n times, so we will remove k, and k is just a constant, so we'll remove that, and then the time complexity of linear search, time complexity of linear search is order of n in the worst case. So in the worst case means if we get a very bad output, this is the very bad output if we don't have any element. So we have so it will go everywhere, compare and then move up, means then move forward, then compare, then move forward. So this is order of n, which is the worst case of linear search, and the best case is O of n. Okay, so this is our thing, and that we have worked. So now let's take a look at the next example. Okay, so in what we are going to do, we are taking the time complexity of an insertion sort. So what is insertion sort? Insertion sort is just a sorting algorithm where we will be given an array. It can be unsorted array. So we have 3, 8, 3, 2, 1, 9. We have to sort in as 1, 2, 3, 8, 9, like that. So this is our algorithm for sorting an array. And soon, and after some day, the student will be seeing sorting and searching algorithms. Okay. So sorting algorithm is just like this. So how do we calculate the time complexity of this algorithm? For taking out the time complexity of algorithm, again let's take two cases. The first case is best case. The best case would be that our array is already sorted. Our array is already sorted. So 1, 2, 3, 4, 5. This is our best case. This is our best case. We are going here, we are checking, we are moving forward. Going here, checking, means comparing with it, means we are moving here, we are comparing with 2, 1, it is good. Then it will go here, it will only compare 3, 2, it will not compare 3, 1, because obviously if 2 is greater than 1, then it's obvious that 3 is also greater than 1. Okay, so it will move, and then it will compare this. This is our best case. This is our best case. Now let's talk about a worst case. What will be the worst case? The worst case is, I have written one array here. The worst case is 5, 4, 3, 1. 5, 4, 3, 2, 1. So this is our worst case example. Means what you have to do, you have to go here, the first element, and this here, and we have to compare it. And we have to compare it, and we have to swap it. And we have to swap it like that. 4, 5, 3, 2, 1. This is. Okay? We compare and swap. Okay? And then we will go further, and then we will compare 4 and 3. Now again we will swap it, and again we will compare for 5 also. We'll compare for 5 also. And then we'll go at 3, 2, then compare this, 2 with 3, 2 with 4, 2 with 5, and then swapping up, and then it will be a large process. So what I can write, first we are going to k, then 2k, we are comparing first 4 to 5, and then 3 to 4, 5. So it's 2k plus 3k, it is 2, 3, 4, plus 4k, all the way down to the n minus 1k. Okay, so we can take out a k as outside, and then we can write 1 plus 2 plus 3 plus 4 plus all the way down to the n minus 1. Okay, and then I can write this kn plus n minus 1. I can write this. Okay, so kn plus n minus 1, and then I will divide this by 2. Okay, and then if I do that, we will get kn plus n minus 1 upon 2. It's a kn straight plus kn by 2, and then we'll remove this low order term. Our time complexity would be order of n squared. And again, I'm re-explaining here. What I've done is I have just multiplied it out. It is not plus, we are multiplying it. So kn squared and kn. Okay, so eventually we'll remove the low order terms, and then we are left with n squared. So order of n squared is the time complexity of insertion sort, which is as bad as selection sort, and do the same for selection sort, and in further we'll be also focusing on this all. Okay, so this is our time complexity. How do we take out time complexity in various cases? And I hope that you got better intuition about all those in linear search and the insertion sort. Okay, so this is how we go further, and I hope that you got better intuition, and you can take a look at my data structures and algorithm mastery course. This is absolutely free with handwritten notes given to you. Okay, so with handwritten notes for free onto the YouTube channel New Era on the playlist Data Structures and Algorithm, and be sure to subscribe to this YouTube channel, press the notification bell, and I hope that you will be carrying out this, and from the next video we'll be actually going to the link lists. No, after just we are just practicing in between. Okay, so link list will be uploaded. Okay, so and again one more course is there, full stack mastery course, and be sure to check it out, the link in the description on this box below. Follow me on LinkedIn, Instagram, and subscribe to this YouTube channel and press the notification bell. Thank you for seeing this video. I'll be catching you in the next video. Till then.